Okay, so what I wanted to do here is I noticed some people are having problems with the set sections on for homework 1.1 and 1.2. These are the ones where in 1.1 it had something like this. You know, we had one, 2, 3, 4. Then it would look like this, like that, etc. And then 1.2 had it with, I believe, hexagons, octagons, I don't really recall. But it's for these types of problems. So I'm going to come up with a new one just on the fly here to kind of show you how to do this. We went over it in class, but I don't think I recorded it, so I wanted to make sure we had this recorded so that when you're doing it for homework, you kind of know what's going on. Essentially what these are doing is we're going to be creating rules so that we can predict this. So just for the sake of fun, what I'm going to say is I'm going to start with something like this. Let's say I had 3 kittens. I'm going to represent that like this. They're going to be boxes because I keep them in boxes because I'm a cruel human being. I have 3 kittens 1 year. The next year, I decide I want to get a couple more. So I end up with 2 more. And then the next year I get 2 more. 1, 2, 3, 4, 5, 6. And so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. There we go. Okay, so what I want to do is I want to show you how this all works. Okay, so what I'm going to do is I'm going to have my step number. I'm going to have that represented by n. And then for this, I'm going to call it k because it's kittens. And then this is going to be my process here. Process, so that you guys see what I'm thinking when I'm trying to build an equation for this. So on step 1, I have 3, and this is my starting position. So I'm just going to call that start. I'm just going to say start there. Then I want to draw your attention to step number 2 here. On step number 2, I have 1, 2, 3, 4, 5. I have 5. So I have my starting position, which is 3, but this time I've added 2. I've added 2 to my equation there. You know, these 2 right here are new. All right. So then on step 3, I have 7. And what I've done is I have 3 plus 2. That's the same as I had in the previous step. But this time, I'm adding another 2. 1, 2. Okay? And so this can go on and on. I don't have to draw it all out. And you can imagine that every month I'm buying more and more kittens. Because I'm doing exactly what I did the month before. But then I'm adding an additional 2. And so what we've done here is we've created a sequence. We've created a series. And I want to talk about how we can turn this into an equation. And so the way that we're going to turn this into an equation is you're going to have the result, in this case k, is going to equal our start amount. Our start. And then we're going to add our rate times n minus 1. And I'll show you why this is. So for this one, I'm going to look at my start amount. And my start amount right here is 3. So in this case, I know I'm going to have 3 right there. And then I'm going to look at my rate. And I see that each and every time I'm doing this, I end up adding 2. So 2 is going to be my rate. I'm just going to write it there. And then I have it n minus 1 times. I just kind of want to explain how I came up with n minus 1. Because this is a good rule to use in a pinch, but I want you to understand why it works the way that it does. Because what we end up seeing here is that we're adding a number of 2's. Right here on step 1, how many 2's did I add? How many 2's did I add? Well, I added 0 here. There's none. There's none there. But here I added 1. Here I added 1, 2. 2. Here I added 1, 2, 3. 3 2's. And I want you to see the relationship between n and the number of 2's. Here the number I have is 1, but I've added 0. 2, 1. 3, 2, 4, 3. I've always added 1 fewer 2 than the step number. right? One fewer 2 than the step number, right? So you can imagine if I were on, if my step number was, say, 78, I will have added 2 77 times. And that's how it's always 1 less than n. So that's how I get this. This is 1 less than n minus 1. So I'm always adding a number of 2's that is 1 less than the step number. And so that's how we get this equation. Use this as your guide for those problems in the set section in 1.1 and 1.2, the ones that look like this. We always have our starting amount. We have our starting amount, and then we're always adding a rate. In this case, it's 3, and we're going to be adding it n minus 1 times. I hope that helps you, and if you have any questions, just see me tomorrow. And that, as they say, is that.